In number 1, I would have rewritten this as the integral of x to the negative second dx. You add 1 to negative 2, that's x to the negative first. You divide by negative 1 plus c. Negative 1 over x plus c. Huh? Minus a half. I make u equal 3x plus 5. du is 3 dx. I don't have the 3. I'm going to put a 1/3 out in front. That gives me u to the negative third du. That's 1/3 u to the negative second divided by negative 2 plus c. We simplify all this, we get negative 1/6 3x plus 5 squared on the bottom plus c.
Why did you simplify it?
Huh?
Like I have negative 2/3.
Shouldn't be negative 2/3 because you divide by the new exponent. One third times negative 1/2 is negative 1/6. No, negative 2 is not an exponent there. This is the same as 1/3 negative 1 over 2u squared plus c. I didn't move the 1. I just put a 1 on top. I didn't move the 1.
What if I had a close answer?
If the answer is incorrect and you have work, you get 1 out of 2 points.
Okay.
If you forgot plus c, you get 1.5 out of 2 points. Number 3, u equals 5x, du is 5 dx. We don't have the 5, we'll put a 1/5 sine of u du. What is the integral of sine of u? So negative 1/5 cosine 5x plus c.
Okay, so negative part of the cosine.
Hmm?
Like I had 1/5 and then negative cosine. Like you have to move it up there.
I would normally move it out in front. It's not necessarily wrong, but yours, if you put a negative here, it's going to look like 1/5 minus.
Yeah, I know.
And that makes it look like it's incorrect.
Okay, so like I still do I still do it?
I put dx somehow in my answer. Is that minus a half a point?
Yes. And here we go, last one. E to the natural log of x squared. At this point, you should know that that just means x squared. That's x cubed over 3 plus c. So count them up, give yourself a score out of 8. So can you imagine me cutting these into those little discs like we did, right? So really what we're doing is we're basically taking the area, so we draw in our rectangle, which is your top minus bottom. Top minus bottom, so this is the equation, top minus bottom, this is the bottom equation, is the x-axis. And the x-axis, that formula would be y equals 0, right? Makes sense? So basically what we're doing is we're taking a bunch of these rectangles and we're squishing them all together to make all these discs in here as we rotate around. This is why this is called the disc method. Now, the first thing we need to understand is what are our bounds? In this case, we're going from what to what? 0 to 4. The 1 doesn't really come into play because it's a y value. top minus bottom. Well, what's the top equation? Negative x over 4 plus 1 minus the bottom equation is 0, and then we square that. Alright, so let's clean this up a little bit. Let's integrate it. How do we integrate it? What's your u? The negative x over 4 plus 1. What's your du? What's your du? What's your derivative of this? What are you confused about? What's the derivative of 2x?
2.
What's the derivative of 3x?
3.
What's the derivative of 5x?
5.
What's the derivative of 1/2 x? What's the derivative of negative 1/4 x? Thank you. Do you have the negative 1/4? No, so I'm going to need a what?
4.
Well, you're going to need a negative 4. So when I plug back in, I'm going to get negative 4 pi u squared du. So when you integrate that, what do you get? So we either have to plug the x's back in or change our bounds. Which one would you like to do? Plug the x back in? Is that what I'm hearing? Alright, so I'm going to make a little change. I'm going to make this negative 4/3 out in front pi. Negative x over 4 plus 1 cubed from 0 to 4. So negative 4/3 pi. I plug in 4. 4 over 4 is negative 1 plus 1 is 0. 0 cubed is 0. Minus. Plug in 0. 0 over 4 is 0. Plus 1 is 1. 1 cubed is 1. So I have negative 1 times negative 4/3. And we get 4/3 pi. Look at the board. Well, I understand you might like the first way better, but that's only because you're used to that formula. This will be more general. Was that we had the line y equals 0, x equals 2, and the graph y equals x squared. So there's the x equals 2. Obviously the x-axis is y equals 0. So this is the area we're trying to rotate around the x-axis. So the rectangle, top minus bottom. What's the top equation? What's the top? So x squared minus the bottom equation. That's the x-axis, which is 0. That quantity squared. We need a dx. We need a pi out in front. We need bounds. 0 to 2. Now we're set up. Take a minute and solve. All right, Mr. Kirby. What did you do?
So first, I picked my u, which was x squared minus 0.
No. No.
Really?
You multiplied it out to be what?
X to the 4th.
And when you integrate it, what did you get?
X to the 5th.
And then you plug in and you get what?
6.4.
Oh my goodness.
5. Okay, 32 to 5 times 5. I have a decimal, my bad.
It's all right. Your decimal was exact.
It had to be less than fraction.
Well, yeah, like, remember, we talked about it before. There are mathletes, and then there are decimal sissies. And as long as you can look yourself in the mirror,
Oh,
it's
I can-
okay.
I can look in the mirror fine.
Okay, then we're good. The square root squared.
Are you squared? I don't see.
Yes, that's what the squared thing is. Top minus.
See that.
The square thing? Proper math terms.
The squared
Thing.
me.
You said square.
Well, obviously I needed to use something that she understood.
Got it, dumb it down.
Throwing shade at me.
Alright, integrate. So 2 minus x squared equals 1. So x squared equals 1. So x equals plus or minus.
One.
I guess. Look at me.
Then why couldn't you just plug it into the calculator?
You could,
Okay.
but we need to know both ways because what if you don't have a calculator?
Then I guess I'm not doing this one.
Alright, so we have our bounds. Up till now we've been rotating about the x-axis, but this time we're rotating around this line. So we still draw in our rectangle. And when we draw in our rectangle, is there any space between the two equations?
No.
And what we're rotating around? No, because we're rotating around this line, so it's just top minus bottom. We know it's negative 1 to 1. We got a pi out in front. What's the top equation?
2 minus x squared.
Minus the bottom equation. So now we have it set up. We can simplify that a little bit. And now we're ready to integrate. And unfortunately, you can't use a u substitution because you're not going to have the derivative of x squared. So we have to multiply this out. We have to square it. So when you square it, you get 1 minus
2x
2x squared.
squared plus x to the 4th.
And now you should be able to do the rest. So I'll give you a minute. When you integrate it, you should have gotten x minus 2x cubed over 3 plus x to the 5th over 5 from negative 1 to 1, and then your answer times pi. Did you get 16 over 15?
No. Yeah. And I have it a different way.
Which is approximately 3.35. So basically you're going to get 1 minus 2/3 plus a fifth minus negative 1 plus 2/3 minus 1/5, and then that should produce this answer.